Welcome back. This is section 2.3, getting information from the graph of a function. So what we're going to look at in this section is how first can we get information from a graph that's given, and then also if we're given a function, how do we then graph it using a graphing device, and then what information can we get from that graph. Okay, so first example here, we got the function t graphed in the figure, and it gives the temperature between noon and 6 p.m. on a certain weather station. Okay, so here's the questions. First thing we want to do is find t of 1, t of 3, and t of 5. So notice in this case, right, we're looking at x values of 1, 3, and 5, and we're trying to find the t value, which in this case is that temperature in degrees Fahrenheit. So we're going to come over here to 1. We're going to follow that up to our graph. We're going to say that this point right here would represent the t of 1. And notice it's halfway between 20 and 30. So t of 1 is equal to 25 in this case. All right, then if we're looking at t of 3, same process. We're going to go over to 3. We're going to follow that up to our graph. That hits that point right there. Notice that's right on the 30 line, and so t of 3 should be equal to 30. And then finally, we have t of 5. Again, I'm going to go over to 5 this time. I'm going to follow that up to my graph. That should hit that point right there. And so notice in this case, that's right on the 20 line, and so t of 5 is equal to 20. All right, now the next question says, which is larger, t of 2 or t of 4? So for this one, we're just going to have to compare the actual t values. So first I'm going to find t of 2, which is this value right up here. And then I'm going to look at t of 4, which is this value right here. And so now if we're talking about which one is larger, the t of 2 value is actually larger than the t of 4 value. So t of 2 is greater than t of 4 in this case. So again, it does not matter what x value we're looking at, right? Because 2 is definitely smaller than 4, but t of 2 is actually smaller than t of 4. Sorry, greater than t of 4. All right, now the next one is we want to find the values of x for which t of x is equal to 25. So now we're looking at values where the t of x is 25. I'm going to find 25 here, which would be this line. Now I want to know what x values would give me a value of that. So I'm looking at where that 25 intersects my graph. It looks like we have a value right here, and then we have another value down here. And so in this case, 1 would be one of those x values. So we would say x equals 1. And then the other value where t of x is equal to 25 would be 4. So x equals 4. So again, just locate that t value and then figure out where your graph actually intersects that t value. All right, and now we want to know the values of x for which t of x is greater than or equal to 25. Well, notice here, my graph is always above that line of 25, everywhere between 1 and 4 this time. So I'm going to have an interval of values from 1 to 4. And because it's greater than or equal to 25, we are going to include the 1 and the 4, because at those points, it would be equal to 25. So that entire interval from 1 to 4, including 1 and 4, would be greater than or equal to 25. And then our last piece here, we want to find net change in temperature from 1 p.m. to 3 p.m. So again, remember that these represent times, right? 1 is 1 p.m., 2 is 2 p.m., and so on. So we're really just finding the difference between t of 3 and t of 1. Okay, because remember, our net change formula is f of b minus f of a. The b value this time would be 3. The a value would be 1. And so we're just going to subtract those t values now. Well, I need to find t of 3 this time. So if I do that, follow that up, it's going to give us a value of 30. And then t of 1, again, if we follow that up to our curve, that should be a value of 25. And so now when we subtract 30 minus 25, that gives us 5. Now in this case, right, because we are looking at a net change in temperature, I am going to include units on this. So notice our temperature is measured in degrees Fahrenheit. So this would be 5 degrees Fahrenheit. What that tells us now is that our temperature went up by 5 degrees because it's a positive 5 between the hours of 1 p.m. and 3 p.m. All right. Domain and range. Okay, so we've talked a little bit about domain and how we find that. We've looked at range slightly, right? But now we're actually going to look at a few more graphs and how we can actually find domain and range for those graphs. Okay, so domain and range can be obtained from a graph by looking, in this case, at the x values for domain and the y values for range. So notice here, this graph starts at a specific x value. I'll just call this A just so we can talk about it. And then it's going to end at this B value down here, right? So our domain would be all the values between A and B, including A and B this time because we do have closed circles at those points. Now, the range, we have to be very careful because we're not just looking at the starting and ending points, we're looking at all the possibilities of y values, right? So the lowest y value this time is at this starting point, but the biggest y value of D actually occurs up here at this turning point, not at the ending point. So when we talk about the range, we have to make sure we're including all of those y values, not just the y values of the starting and ending points, okay? All right, so now we're going to use a graphing calculator to sketch our graph of square root of 4 minus x squared. Now, I'm actually going to use Desmos to do this, right? And then we'll actually look at the graph together. I'm going to switch over to my Desmos graph now. And so we're graphing f of x equals square root of 4 minus x squared. That's what our graph looks like. And then if we want to, we can actually zoom in a little bit because it is just that little piece of the graph right there. Now, once we've done that, the next piece of this asks us to think about domain and range. Okay, so we'll discuss that, and then I'll switch back to the slide so we can see it together. So if we're looking at domain, we're thinking about all the possibilities of x values for this graph. So basically, I'm thinking, well, this graph starts over here at this point, and it ends over here at this point. So my possibilities of x values range from -2 to +2. Notice here those endpoints are included on the graph, so we are going to include those in our domain. So we are going to use brackets. So it's going to be a bracket, -2 to +2 with a bracket. And again, I'll switch back over to the slide so you can see what that looks like. The next piece of this is the range. So now if we look at range, we have to think about all the possibilities of y values. Well, notice for both of those endpoints, that lowest y value is 0. So we are going to start with 0. It is going to be included. We're going to have a bracket and 0. Then we need to figure out what's the highest possible y value, which is actually this point right up here. Okay, and so the y value at that point is 2. Again, that point is included. So it's going to go from 0 to 2, both with brackets because both of those points are included now. Okay, so domain goes from -2 to +2. That's our x values. The range goes from 0 to 2. Those are the y values. And in this case, all of those endpoint values are included in the domain and the range. So I'll switch back over now so you can see what that looks like. So there's the domain and the range for that function. All right, now we can actually solve equations and inequalities graphically. Okay, so there's a couple of different ways to do this. We can actually graph both functions, which are both sides of our equation or inequality, and then we can just look for points of intersection. The other way, which is the way I'm going to always do it, is actually going to be to set the thing equal to 0 first, and then we're actually going to figure out where it crosses the x-axis, okay? So just know, right, if you want to graph both sides and find points of intersection, that definitely works, but setting it equal to 0 and then finding the zeros or the x-intercepts of the function also always works, and it's a more consistent way of doing it throughout all of the problems that we're going to do later, okay? And so that's the way I'm going to set these up. So the first thing I want to do with this one is move everything to one side, set it equal to 0, which means I'm going to have to subtract 2x squared, and I'm going to have to subtract 5x. Whatever I do to one side, I have to do the same thing to the other side. So now we're going to be left with x cubed. I'm going to try to keep these in order, minus 2x squared, minus 5x, and then plus 6, and that's going to be equal to 0. Now what I'm going to do is I'm actually going to graph the left-hand side of this equation, and I'm going to figure out where it's equal to 0. In other words, I'm going to graph it, and I'm going to figure out where it crosses the x-axis. So again, I'll switch over to Desmos. And so we're graphing f of x equals everything on the left-hand side. So x cubed minus 2x squared minus 5x plus 6. Now, I can't really see the top and bottom of this function. If you wanted to adjust your y values to see those, that's fine. But again, all I really care about are the zeros of this function. Where is this equal to 0? And that's going to be at all the x-intercepts. Well, Desmos is nice in that it actually marks those points for us, and we can just click on them, and that will actually give us all of our solutions. So in this case, it's all of those x values. So it's going to be x equals -2, +1, and +3. So those will be the solutions to this equation now. So again, just move everything to one side, graph the function that we have there, and then look for those zeros of that function. All right, so now I'm going to switch back over to the notes so we can look at the second one here. All right, so the next one we've got is an inequality. Notice all the values are the same. We're still going to do the same thing in moving everything to the left-hand side. So when we do that, it should give us exactly the same thing we had before, x cubed minus 2x squared minus 5x plus 6. But this time, this is going to be greater than or equal to 0 instead. Now, we're still going to be able to use our graph to figure this out. This time, though, instead of just having those specific values where it's equal to 0, we're trying to find all the values on that graph, all the x values, where this graph is either greater than or equal to 0. So again, let's switch back over to Desmos. It's going to be the same function that we already had graphed there. All right, so if we look at this graph now, we have intervals where this graph is greater than or equal to 0. Well, we know it's equal to 0 at -2, and it's equal to 0 at +1, right? Because we found those points. But now, everywhere in between that, the graph is above the x-axis, meaning that it's greater than 0 now. So we're actually going to have an interval of values from -2 to +1, where this thing is greater than or equal to 0. Now, because it's greater than or equal to, we are going to include the endpoint. So this is going to be bracket -2 up to +1 with a bracket. That's one interval where this is greater than or equal to 0. Now, if we continue on, we can see that once we get past 3 down here, the rest of this graph is also greater than or equal to 0 because it goes above the x-axis and it never comes back down. And so now we're going to have another interval that starts with 3, again, including the 3, so we're going to use a bracket. And then it's going to go all the way to +infinity. And remember, infinities always have parentheses. So I'm going to switch back over to the notes now so you can see what I've written there. Okay, so again, we had that interval from -2 to 1. That's one area that was greater than or equal to 0. And then we also have the interval from 3 to +infinity. That was also above the x-axis, also greater than or equal to 0. And because we have multiple intervals this time, just remember we're always going to put a union in between there. So this would be our solution set to this inequality. All of the values in those intervals would work for this inequality now. Again, in general, with equations or inequalities like this, Move everything to one side, get 0 on one side, and then that way we can just look at the zeros or x-intercepts of our graph and then compare whether it's either an equation, it would just be the x-intercepts themselves, or if it's an inequality, we're either looking above or below, depending on whether it's greater than or less than. All right, increasing and decreasing. Okay, so this definition that they give you is a little weird to try to read through, right? So it says an interval I is increasing if f of x sub 1 is less than f of x sub 2 whenever x sub 1 is less than x sub 2 in that interval. Basically, if we can just look at the graph and read from left to right and say, oh yeah, it's going up from left to right, that means it's increasing. And then when we read from left to right, if it's going down, we say it's decreasing, right? So that's all you really need to worry about in terms of this, right? So the definition, it has to be very precise, but really it's just a matter of looking at the graph and determining, is the graph going up or is the graph going down? But again, always read from left to right when you're determining increasing and decreasing. Now, the intervals for increase and decrease are always going to be in terms of our x values, okay? So that's the main thing we have to keep in mind when we're writing these intervals. We're looking at the y's to determine if it's increasing or decreasing, but the intervals themselves will always be in terms of the x values. All right, so let's take a look here. They give us a graph, and we just want to determine where are the intervals where this function is increasing and where is it decreasing. Okay, so I'm going to start here, just labeling increasing. And so if we start at the beginning, again, reading from left to right, from 0 all the way to this point right here, which is at 20, that function is increasing, right? It's going up from left to right. And so we can say in this case that our increasing interval is going to be from 0 to 20 is going to be an increasing interval. Now, in general, when I do increasing and decreasing intervals, I'm never going to use brackets because technically at the endpoints themselves, it's not increasing or decreasing, right? Okay, that's a fixed point. Okay, so it's the values in between 0 and 20 this time that are increasing, and so I'm just going to use parentheses to label that. All right, so since we're on increasing, let's see if we can find another increasing interval. And I look down further and I say, well, starting from this point right here and going to this point right here, that graph is also going up from left to right. So we have another increasing interval. And if we figure out what those values are, it looks like this first one here is at about 35 and the next one is at 40. And so we have another increasing interval from 35 to 40. Now, those are the only two intervals where this graph is going up, right, where it's increasing. So now let's look at decreasing. Well, I only see one interval where the graph is actually going down from left to right, and that's from this point here to this point right here. So we said that that point, the first one is at 40, so we're going to have a decreasing interval from 40, and then it's going to decrease all the way to this next point, which is at 50. And that's our only decreasing interval. Now, all the other intervals, or the other two intervals that we did not list, okay, it's flat along those. We would call those constant, right? So in general, when we're listing out increasing and decreasing, you're only looking for where is it going up, where is it going down. We don't really care about the constant intervals. We're not going to label those or list them out. And again, keep in mind here, notice all of these values for increasing and decreasing, they're all in terms of this x-axis. We're using the w-axis, right, the vertical axis to determine where it is going up and down. We only list the intervals in terms of the x values. Okay. All right, so now let's see if we can find intervals of increase and decrease for a given function. So we've got 12x squared plus 4x cubed minus 3x to the fourth. Okay, so we're going to sketch that graph. We're going to talk about domain and range. Okay, so I'm going to do all these things while I'm on the graph, and then we'll come back and actually look at them together. And then we're also going to look at intervals where it's increasing and decreasing. Okay, so I'm going to switch over to Desmos so we can graph it. Okay, so we've got f of x is equal to 12x squared plus 4x cubed minus 3x to the fourth. So there's our function. Now this time we are going to need to zoom out a little bit so that we can actually see the top of our graph. So I'm just going to change my y value here, make it a little bigger, still not big enough. I'm going to make it bigger than that, and bigger than that. There we go. Okay, so now I can at least see the top of my graph, and I can see all the turning points, right? Because that's what I really need to determine increasing and decreasing when we get there. All right, so there's our graph. Now let's talk about domain and range. Well, in this case, we've got a polynomial function. There are no restrictions on what that x value can be. So the domain this time is actually going to be all real numbers from negative infinity to positive infinity. So that's the first step. Now let's talk about range. The range is all the y values. We'll notice that our graph here goes all the way down to negative infinity, right? It's going to continue on forever down to negative infinity. So we need to start our range at negative infinity. And then we need to figure out what's the highest value of y that this function hits. Well, again, in Desmos, it actually will mark these highest points for us. So I can look there and say, well, the highest y value that I'm attaining is 32. So my range goes from negative infinity to positive 32. In this case, the 32 is included, so it's going to get a bracket. And again, I'll switch back over in just a minute so you can actually see what I've written down there. Okay, but for right now, I want to stay on the graph so we can get the rest of these intervals. All right, now let's look at increasing and decreasing. Okay, so we're going to talk about increasing. Our first interval, reading from left to right, is increasing all the way until we get to this point right here. Again, our intervals are always in terms of x values when we're talking about increasing and decreasing. So the x value at that point is -1. So that first increasing interval is going to go from negative infinity to -1. And again, I'm always just going to use parentheses because at -1, it's technically not increasing or decreasing. Now, the next interval here from -1 to the origin is decreasing now. So again, in terms of x values, we have a decreasing interval, and it's going to go from -1 to 0. Okay, then starting at 0, the function starts increasing again. It's going to increase from 0 all the way to that highest point. The highest point's x value, though, is 2. So that interval is from 0 to 2. And a common mistake there is people want to put 32 as that increasing interval because that's the highest value. But again, our interval only is in terms of x's, so it's from 0 to 2 this time. All right, and then once we get to 2, then it starts decreasing again. And so this is actually going to decrease from 2 all the way to positive infinity. All right, so I'm going to switch back over now so we can look at those together. All right, and so there's our domain and our range like we talked about, and there's our increasing and decreasing intervals that we talked about also. All right, so local min and maxes. Okay, so we can also use our graph to help us find local min and local max points. Now, what we mean by local min and local max is they might not be the absolute highest and lowest points on the graph, but they could be just a local turning point of our graph, right? So that's what all this notation basically tells us. If we have a local highest point on our graph, it's a local maximum. A local lowest point on our graph is going to be a local minimum, but they don't have to be the absolute highest and lowest. Okay, they just have to be turning points. Okay, so example 8 here, we're going to find the local max and local min values of this function. Okay, so again, I'm just going to switch over to Desmos so we can find those. All right, so we have f of x is equal to x cubed minus 8x plus 1. Right, and based off the window that I already have there, I can actually see my highest and lowest points. So again, all I really have to do in Desmos now is select those points. And I can see here that I have a local maximum at negative 1.633, 9.709. Okay, so that would be what we call a local maximum. Now, down at the bottom there, we have another turning point, but this time it's a lowest point, right, where it turns. And so that would be considered a local minimum. And that point occurs at 1.633 and negative 7.709. Now again, these are not the absolute highest and lowest points of our graph. They are only turning points of the graph, so we call them local min and local max values. So I'll switch back over so you can see what I wrote there in the notes. And so there was our local max. That was at negative 1.633, 9.709. And our local min was at 1.633, negative 7.709. Now, if they are asking you for values, okay, so local min and max values, the actual local max value is only going to be the y value, right? So this is mostly for if you're doing problems in WebAssign and they only ask you for the min or max value. We only want to include the y value, and so that would be our answer. And then same thing with the local minimum value. We would only include the y value, and so that would be negative 7.709. So if we're looking for local min and max, it's the entire ordered pair. If they ask for a local max value or a local min value, they only want the y value at that point instead. All right, and that's it for that section. So again, as always, let me know if you have any questions. Come see me during student hours if you need to. Send me those questions in WebAssign using Ask My Teacher. I will see you next time.